Okay, we're going to continue graphing piecewise functions, and this is what I know we accomplished in class. If you did a little bit more, then that's great. One thing about piecewise functions, when we're beginning learning, you can use lots of colors and highlighters and things like that in Math 3 and in pre-calculus. But then once we get to calculus, you should be able to graph these with just a pencil and it should just look clean and simple. And in college, definitely no colors, because usually math professors are very strict about pencil and paper. So one way we would use a highlighter would be to talk about the domain. So the domain of this first parabola here is -1 to 4, like that. For the x's, x is domain, y is range. So you can see here that this parabola is only graphed from -1 to 4. Okay, so here I highlighted in green matches what I graphed here, down here, from -1 to 4. And then for all the x's greater than 4, we see that's here from 4 and then on. Those are the x values greater than 4, whereas these x values are between -1 and 4, and we have nothing over here. Okay, so it's a little messy, but if it helps you learn and match them, because here's what the deal is, you guys. These are side to side, and then you have to like turn it and go like this, okay? So top and bottom is what I meant, and then x's are side to side. Okay, let's get on to these next two examples. So first of all, you need to identify, well, do we have a point to plot on number 3? Do you guys see a point? I see one. So this middle function here is going to be the coordinate point, and the x value is 0 and the y value is 2. So that's what we learned today. That's new today. So we're going to make one big point here at 0, 2. Okay, and then next, these are at least the same parent function instead of two different parent functions. So do you know what the name of this is? What is this parent function called? So this is a square root. And then do you know what it looks like? So in your head, you should think 0, 0, 1, 1, 4, 2. And that's the arm that it looks like. Now we need to do the transformations. So the negative x, if we're going to make all of these x values negative, where is this going to go? Think if these were all positive, but now they're going to be negative. So it's going to be a flip over the y-axis. So because of this negative x, it's going to look like this now. And then because of the +3, it's going to be moved up 3, because that +3 is outside of the square root. So let's think about this. Really lightly, here's my flip. Do you guys see that? It's almost like I'm pretending, like it's in my head. Announcements? Okay, so here is my square root, and I flipped it already, check, but now I just need to move it up 3. So I'm at 0, 0, and I'm going to go 1, 2, 3. This one was here, 1, 2, 3. This one was at 4, 2, 1, 2, 3. And I'm not concerned with the domain yet because we're just practicing this, you guys, right? Do we know, we have bigger graphs today. Do we know the square root of 9? Isn't the square root of 9 3? So where's this next point going to be? If the square root of 9 is 3, then we're going to move it 3 more up. So look how fancy we are. Doing another point there. How come we didn't do that before? Well, remember the graph just ended at 8, I think. So we just have more room. Okay, there's my square root. How's it look? It's okay. And then this one, no flip. Oh, so it's just the regular square root. And all we're going to do is do what? We're going to move it up 3, but that doesn't say up. It says yep or something. Okay. Up 3. So I don't want this anymore. That was just that. Okay. my parent function starts at 0, 0, and we're going to move it up 1, 2, 3. It was at 1, 1, 1, 2, 3, and it was at 4, 2, 1, 2, 3. And then we know the square root of 9 is 3, right? So that's also part of the parent function. And we're just going to move this point up 1, 2, 3. Do you know what this reminds me of? It reminds me of those birds you used to draw in elementary school. And the teacher said, draw a picture. You're like, okay, I'm going to put a bunch of birds on it, right? Okay, let's see here. What is this? This is only supposed to be from -4 to 0 and opened or closed here. If it has a line underneath it, it's going to be a closed circle. And what about on the 0? That's going to be an open circle. So what are you telling me? You're telling me that I found this point way back here for no reason? Oh well. Okay. So what color should I do this one in? How about red? Okay, so this one's going to be in red. And I have an open circle, just kidding, closed circle at -4. And I'm going to follow this down, but then I need an open circle in 0. So we're going to, where's that cool eraser? Okay, so this is going to be open here. Is that neat? All right, and then pretty in pink, we have this bottom graph that I sketched here, and we're going to graph it only for the x values greater than 0. And that's going to, is that opened or closed? It's going to be open. Do you know why? Because there's no line underneath it. So this will also be an open circle. So you guys, we have an open circle and an open circle, and that's okay. But then the rest of it, it's all the x's, correct? It doesn't stop somewhere. So we do get to use this point, yay, that we found at 9. Okay, what do you think? This is the top function. Here's my point in the middle, and then there's this bottom function here. Beautiful, huh? I think this is so much fun. If you think this is fun, if you think it's difficult, you're right. It is difficult. It uses a lot of things that you just learned in a week. So, oh, okay. This has the reflection and the shift, which I think is the most confusing thing we've talked about so far. But we are using the square root, which, do you guys agree it's the same shape as this one? So -x plus 2. Now you need to go look up at your notes. Look at your examples. What are you supposed to do here? Okay? You either have it memorized or you're still using your notes. Now, if there is a negative in front of the x, a negative in front of the x means all the x values are positive are going to become negative. So that's a reflected, oop, golly, my spelling's bad today. We just have, you know, it's good days and bad days. And today's, my hand isn't doing what my brain is telling it. So, reflection over y-axis, okay. Now, because I factored out the negative, I get to keep my same rule, and the rule is that it's the opposite. So this said +2, it needs to be moved to the left 2, and the +2 on the outside means up 2. And we're only going to graph it for the x values less than -2. Now, I can't do this part and these 3 all at the same time. So I don't think you should either. So let's see here. We have to reflect it over the y-axis. So do you agree with the same parent graph that we did before? Okay, 0, 0, like this. And we need to move these points to the left 2 and up 2. So 1, 2, 1, 2. That was my first point, my origin. Now I'm going to take this point. Left 2, up 2. And now this point, left 2, up 2. And this 9, left 2, up 2. Now, oh my gosh, it should be a little confusing. You need to erase the original parent graph. There. Does that look good? that's what we're supposed to graph. Did I do that right? Let's double check. Reflect over y, left 2 up 2. Okay, now this only exists for the x values less than -2, but not including -2. So at -2, we need an open circle. And because there's not a number over here, so over here, we had to stop at -4. This doesn't have a stopping point. This says, hey, every number less than -2. So we're going to go like this, and this gets to have an arrow because it's all the x values less than -2. Where this one stopped at -4, this told us to put a closed circle here. Okay, I'm going to sneeze. Watch out. Okay, I hope that didn't hurt your ears. That's our top one. Whoa, that was a lot of work. Okay, let's look at the middle. Tell me what is the parent function here. What's the name of this function? Do you agree it's linear? Okay, so if it's linear, we have a y-intercept and a slope. I'm going to start with a pencil. So my well, what's the y-intercept? What's the slope? You'd get the same answer, right? So the y-intercept's -2, so that's down here. And my slope is -2 over 1. -2 over 1, -2 over 1. Oops, I'm off the screen. And continue the pattern going in the other direction. So that would be up to left 1, up to, and look, we end up, it touches this point, right? That's cool. Okay, are these going to be open or closed? They're both open. Open, 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 open. So this one has no closed connector points. So at -2, we're open. Okay, so those are overlapping. And then what x value was I supposed to stop at? We're supposed to stop at 1. So let me connect my dots until I get to x equals 1. Is that right here? And then that's going to be an open circle. So my pencil marks are still there, but that's why we do it in pencil, so that we can erase. And my goal is, I hope my eraser doesn't mess up my pen. Oh man, that's awesome. That's what you get for paying for high quality. What are these? Papermate Inkjoy, brought to you by, just kidding. Okay, so there's my line. Everyone okay? We keep going? Last one, 3 transformations, and I have 2 minutes. We can do it. Okay, negative in front is a reflection over, now that was the y-axis, so this is going to be the x-axis, x-axis. What about the -1 inside? -1 inside means we're going to go right 1, and the -4 on the outside means we're going to go down 4. Awesome. Okay, so a reflection over the x-axis would look like this. 1, 1. We're doing square roots, right? Square root of 4 is 2, square root of 9 was 3. 1, 2, 3. So there's my reflection, but now we need to move these 4 points to the right 1 and down 4. So here we go. Right 1, down 1, 2, 3. What do you notice? We ended up right here, which is good. Here we go. This one, to the right 1, down 1, 2, 3, 4. To the right 1, down 1, 2, 3, 4. To the right 1, down 1, 2, 3, 4. Hey, if at any time you think like I made a mistake on a video, please feel free to share with me in class, okay? I hope I don't, but I'm doing this by myself, and usually in class, you know, we have all those eyes watching me, so kids. Let's see, are we stopping anywhere or we're just going? We're just going, right? All the x's are greater than 1. All the x's are greater than 1. Is that not like the coolest graph you ever did see? So it starts off curved, and then there's a hole, then it goes a straight line, a hole, and then another curve. Man, you guys should show your parents this, okay? All right, I'm done. Announcement messed me up. I hope you guys have a great day. Thanks for watching. Bye.